Okay, so we will continue for the subtopic 7.3. So I hope you're already clear with the 7.2. Let me give some notes here. Okay, please put some notes, which is subtopic 7.2. Okay, for subtopic 7.2, your inequality is very important. But as for subtopic 7.3, your inequality is not really important. And another one thing, for the subtopic 7.2, you'll be having some additional subtraction to find your PDF and CDF. But as for subtopic 7.3, you'll be using integration and differentiation to find your PDF, to find your CDF. Okay, so 7.3, of course, you'll be having your PDF here, and you'll be having a CDF here, and probability from a PDF and CDF, and probability of distribution function here. Probability density function from a CDF and vice versa. So means we'll be having PDF to CDF, CDF to PDF. Actually having the same thing that, okay, having the same learning outcome from the 7.2, just this is for the continuous random variable. As we know, what we are going to have as a continuous random variable, it is a not countable. So in highlight, this is not countable. As for discrete 7.2, it is a countable. Okay, so let's proceed. Okay, this is the definition for the PDF. So for the first one, so as you know, for the PDF, we are going to represent it as a small letter of fx here. Okay, as a small letter of fx. And the next one, which is the first one, it must be greater than or equal to 0 for all of x, and which is the integral from the negative infinity to infinity, which is the least one until the greater one here of the PDF must be equal with 1. Let's proceed. So this is just some figure which is is shown to you, which is, as I told you, in the continuous random variable, we'll be having some integration. So as we know, integration, we are going to find some area, is it right? Then the next one, which is right. Okay, so if you try to look at here for the PDF property of x between of a and b, it will be equal to what? A small letter of x here. The function here integrate from the a until b, so which is enclosed from the area from a until b here, which is the x-axis. So this is the graph, which is y equal to fx. So this is the shade area here will be our area lah. So let's proceed. Okay, which is the second one, which is property of x is equal to k, because 0 here, where k is a constant. Then actually, as I told you, this is just what they want to say here. Do not worry about inequality, which is inequality for the continuous random variable is not important as our discrete distribution. So you may put some notes there. So let's proceed. Example 7.13 here. I already have a solution, don't worry. So it is given to your continuous random variable x has a PDF. Okay, this is given to a function. Okay, for x between of 1 until 3. The first question asking to sketch the graph and verify that it is satisfy the condition of a PDF. So as we know, for the PDF, we'll be having what, which is the integral of the function, the fx here, from 1 until 3, it must be equal with 1. So as we know, as you can see from here, it must be equal with 1, right, from the second property here. Okay, so then the next one, which is what, sketch the graph. So as you can see, this is the graph for the PDF for the continuous random variable. When the x is equal to 1, substitute x is equal to 1 here, what you get, x is equal to 2, what you get here, x equal to 3, what you get over here. As you can see, the difference between the graph, okay, the graph between PDF for the continuous random variable and discrete random variable are different. So this is the graph for the PDF for continuous random variable. So you can see there is some shaded region here. Okay, so then the next one, the question asking to find property of x less than 2. So you can see over here, they just want to find, they just want to find the integral of fx, the PDF here, from 1 until 2 only, because the question asking for the x less than or equal to 2. As you can see, the inequality is not really important. We are going to have until 2. So you may use calculator to have your integration here. So you'll be having 5 over 8. So let's proceed, which is example 7.14. So I already have a solution, don't worry, which is it is given to PDF. Again, as I told you, PDF will be having small of fx. This is a piecewise function, and the loss of it must be having a 0 here, which is put it have a otherwise. Okay, find the value of constant k. How can we know the value of constant k? As we know, we'll be having what? Okay, so the total area of the function must be equal to 1, is it right? So the first function will be having kx plus 1 here, from 0 until 2. So we will be having some integration for kx plus 1 respected to x from 0 until 2. Add up with a second function will be 2k respected to x here from 2 until 3. And the total of it must be equal with 1. So you need to have a difference. Okay, you need to separate the integral here. So you must sum of it must be equal with 1. So from here you can have the answer for the k. So I hope you already clear about this part. So that's why we are learning topic 6 from the semester 1 about the piecewise function. Okay, so question B, sketch the PDF. Okay, to sketch the PDF, so you know the k will be equal to 1 over 6, right? Just substitute k is equal to 1 over 6 here. So this will be a piecewise function for the PDF for continuous random variable. Okay, so you must put some notes here. This is a PDF. Okay, PDF for continuous random variable. So this is the graph. So you can see the difference between the graph of continuous random variable and discrete random variable for the PDF. Each of it are different. So let's proceed. The next question asking to find the property of x between of 1.5 until 2.5. So if you try to look at here, it is a whole number from 0 until 2 to until 3, is it right? But to look at here carefully, the question asking from 1.5 until 2.5. 1.5, where are we going to find the 1.5, which is on the first range, is it right? In the first range, I'm sorry. So 1.5 in between of 0 and 2, and 2.5 in between of 2 and 3. So we are having a different function. So look at the solution. So what do you have over here? So you'll be having, since we want the property of x between 1.5 and 2.5, so you are going to find the first function from 1.5, the limit is until 2, is it right? So we are going to integrate until 2 plus with, we are going to start from 2 until 2.5 because that's question 1. So do some the normal integration that we have before. So you may use calculator, so therefore you got the answer over here. I hope you're already clear about this part. Next, question D. Question D asking property of x greater than 1.8. But the problem one, if you want to find which is more than 1.8, having a little bit problem, which is actually having the same solution as question C. You may have 1.8 will be where? Will be in between of 0 and 2, is it right? But we just want from the 1.8 until 2, and the next one will be having from 2 until 3 for the second function, right? But as for this one, question D, you may look at the solution. We have another one solution, which is what you can do it this way. 1 minus property of x less than or equal to 1.8. Just integrate, which is you just need to integrate only one. You just need to integrate only one function instead of you need to integrate two functions as in solution C here. Okay, if you want to try, okay, you may try another one solution for this one, question D here, as in the same pattern as solution C here. So you already have the answer. Okay, 7.15, it doesn't have a solution and doesn't have answer, but you may try to do it first. Okay, 7.15, I'm just going to give the answer, which is the value of P will be equal to -1, the value of Q will be equal to -1, the value of K will be equal to 1 over 2. So you may try it first.